Good morning, students. I'm Sangeeta, lecturer in chemistry, branch general section, Institute GPT Narankhed, semester 2, subject engineering chemistry and environmental studies, subject code 18C204F, major topic principles of metallurgy, duration 30 minutes, subtopic extraction of crude metal, teaching aids, PPT, animations, diagrams wherever required. So today's our topic is extraction of crude metal. Let us recollect what we have discussed in last class. So in last class we have discussed these three topics: hand picking, levitation or gravity separation, and fourth flotation process. Among these three topics, this third one, fourth flotation process, is in your syllabus and it is very important. So once again we will revise this fourth flotation process. So this is one of the methods of concentration of ore. So what is meant by concentration of ore? The process of removal of impurities from ore is called concentration of ore or dressing or benefaction, and the resultant ore is called concentrate ore. So these are the three methods used to concentrate the ore. So among these three, so this one is important and this one is in your syllabus. So we will see that fourth flotation process. This method is used for which ores? For sulfide ores. To concentrate sulfide ores, we will use this fourth flotation process. So and this is also used in case of ore containing very small quantity of mineral particles which are not easy to separate from gangue. So for example, zinc blende and iron pyrites and copper pyrites are concentrated by this process. So what is the principle involved in this process? This is based on the difference in the wetting of mineral particles and gangue particles with oil and water. It is called preferential wetting. That means here mineral particles are wetted with oil and gangue particles are wetted with water. That is the meaning of preferential wetting. Then come to the process. So here I will show the diagram. So here we are taking one large tank. In the tank we are adding a mixture of water and pine oil or olive oil. To that mixture we are adding powdered sulfide ore. Then we are adding one frothing agent called sodium ethyl xanthate. Then we are passing a strong current of air more than 2 atmospheres, okay, to agitate that mixture. So that what happens, that mixture will mix well and foam will be produced. And foam will come above. With that foam, these ore particles also come above. Okay, so here we are adding collectors. Collectors enhances the non-wettability of mineral particles, and we are adding stabilizers. Stabilizers stabilize the froth, and conditioners make the ore particles to float in that suspension. Okay, after getting the foam will be collected into the another container and allow it for few minutes. Then foam will disappear and the ore particles will be separated out, and whatever the gangue particles present in the ore, they will go and settle at the bottom of the tank. Okay, then here mixture of sulfide ores, for example ZNS and lead, PBS, lead sulfide, are separated by using a depressant called as sodium cyanide. Okay, this is the fourth flotation process. So today our topic is extraction of crude metal. So our topic is extraction of crude metal. So after concentration, what we will do? We will extract the metal from the ore. So what are the objectives? On completion of this period, you would able to understand these three topics: roasting, calcination, and smelting. Okay, these are the steps involved in the extraction of crude metal. Our topic is extraction of crude metal. So extraction of crude metal is done in three steps, that is roasting, calcination, and smelting. So first one we will see the roasting. So what is meant by roasting? Heating of the ore either alone or mixed with other substance in presence of air below its fusion temperature is called roasting. So here what is roasting? So we are heating the ore either alone, that means separately ore is heated, or mixed with other substance, that means you can add some other substance to the ore, then you can heat in the presence of air below its fusion temperature. So every metal is having some melting point. Fusion temperature means melting point. So below its melting point only you have to heat the ore. So that is called roasting. So what is roasting? Heating of the ore either alone or mixed with some other substance in the presence of air below its fusion temperature is called roasting. Roasting is employed in case of sulfide ores or the ores containing metal sulfide impurities. So roasting is employed in which ores? In sulfide ores. For example, lead sulfide, zinc sulfide, like that. Or the ore containing metal sulfide impurities. Some of the ores containing metal sulfide impurities. In that cases, we will apply roasting, and in case of sulfide ores, we will apply roasting. And sulfide ores are converted into oxides or sulfates. So during roasting, sulfide ore can be converted into oxides or sulfates. Roasting involves chemical changes like oxidation, chlorination, etc. It means during roasting, oxidation can take place, chlorination can take place. This process is carried out in reverberatory furnace. So different types of furnaces will be there. So here roasting will be carried out in which furnace? Reverberatory furnace. So okay. So roasting is employed in case of sulfide ores or the ores containing metal sulfide impurities. So during roasting, sulfide ore is converted into either oxide ore or sulfate ore. And roasting involves chemical changes, oxidation, chlorination, and this will be carried out in reverberatory furnace. Okay. And types of roasting. So roasting is again classified into three types on the basis of nature of product form. So during roasting, what is happening? Some products are formed based on the nature of the product forming. Roasting is divided into three types. So that is oxidizing roasting, okay, sulfating roasting, or chloridizing roasting. So based on the nature of the product form, the roastings are of three types: oxidizing roasting, sulfating roasting, and chloridizing roastings. Now we will see one by one. The first one is oxidizing roasting. So this is common type of roasting and used to remove sulfur and arsenic in the form of their volatile oxides. So this is the common type of roasting, and this is used to remove sulfur and arsenic. So why we will use this roasting means whatever the sulfur and arsenic present in the ore, that will be removed in the form of their volatile gas oxides, means in the gases form. Okay. During this process, sulfide ores are converted into oxides. It is applied to the ores of iron, lead, zinc, nickel, copper, etc. So during oxidizing roasting, sulfide ores are converted into oxides. That means lead sulfide will be converted into lead oxide. Zinc sulfide will be converted into zinc oxide. So it is applied to the ores of iron, lead, zinc, nickel, copper, etc. So this is a very common type of roasting, and it is used to remove sulfur and arsenic in the form of their volatile oxides. That means in the form of gases they will be removed off. So during this process, sulfide ores are converted into oxides. So we will see the equations here. So if you see here, copper sulfide, lead sulfide, zinc sulfide, iron sulfide. So what we are doing, we are heating in the presence of oxygen. Roasting means heating the ore in the presence of oxygen, either alone or in the presence of another substance. So what is happening? Sulfide ore is converting into oxide ore. So this is oxidizing roasting. Okay, so in oxidizing roasting, the sulfide ore is converted into oxide ore, and whatever the impurities present in this one, the sulfur will be removed as sulfur dioxide. Okay, Cu2s plus O2 gives rise to Cu2O plus SO2. So your balanced equations are given. PBS plus O2 gives rise to PBO plus SO2. ZNS plus O2 gives rise to ZNO SO2. FeS2 plus O2 gives rise to Fe2O3 plus SO2. Means all sulfide ores are converting into oxide ores, and the sulfur will be removed in the form of sulfur dioxide. If any arsenic also present, they will also removed in the form of volatile oxides. This is about oxidizing roasting. And second one is sulfating or partial oxidizing roasting. So here, this type of roasting is carried out under controlled conditions. A part of sulfide ore is converted into sulfate and rest is converted into oxide. So this is carried out some control conditions here. Some of the sulfide ore is converted into sulfate ore and the rest is converted into oxide ore. So in the first one, what is happening? Total sulfide ore is converting into oxide ore. So here what is happening? Some sulfide ore is converting into sulfate ore and the remaining is converting into oxide ore. That's why it is called as partial oxidizing roasting. Partial meaning half. It means half is converting into oxide ore and half is converting into sulfate ore. So as it is converting into sulfate ore, this is also called as sulfating roasting. So sulfating roasting or partial oxidizing roasting. Some of the sulfide ore is converted into oxide ore and some of the sulfide ore is converting into sulfate ore. So we'll see the examples here. So roasting of galena means PBS, leads to formation of lead oxide and lead sulfate. So if we eat PBS in the presence of oxygen, so what is happening? So PBO plus SO2 and some of the lead oxide is lead sulfur is converting into PbSO4. That means two products are forming. Lead sulfide is converted into lead oxide and lead sulfate. Similarly, zinc blend on roasting use zinc sulfate and zinc oxide. ZNS plus O2 gives rise to ZnSO4. ZNS plus O2 gives rise to ZnO plus SO2. Okay. So here, in sulfating roasting, what is happening? Some of the sulfide ore is converting into sulfate ore. This is the sulfate ore. And some of the lead sulfide or sulfide ore, zinc sulfide is converting into zinc oxide. So you see here, PBS, PBO plus SO2. It is converting oxide ore, sulfur will be removed off in the form of sulfur dioxide. It is converting into lead sulfate, totally it is converting into lead sulfide, is converting into lead sulfide is converting into lead sulfate. Similarly, ZnSO4, ZNS plus O2, ZnO plus SO2. Like this, sulfate ore and oxide ore are forming in the sulfating roasting. Okay. And third one is chloridizing roasting. This type of roasting is used in case of silver ore. So where we will use this type of roasting means in the case of silver ore. Argentite is heated with NaCl at 600 degrees centigrade, use AgCl and Na2SO4. So during definition only in the starting itself, we said that ore is heated alone or by adding some other substance also we can heat. So in chloridizing roasting, what we are doing, we are adding some substance to the sulfide ore, then we are heating in the presence of oxygen. Okay, so here we are adding sodium chloride and we are heating in the presence of oxygen. So this is silver sulfide, NaCl, sodium chloride and oxygen. It is converting into silver chloride and sodium sulfate is forming. So this is also a roasting, that is chloridizing. Why we are saying chloridizing roasting? Silver chloride, based on the product only we are giving the name. Okay, so silver chloride is forming, that's why it is chloridizing roasting. So this argentite means this is silver sulfide is heated with what? NaCl, some other substance, At what temperature? At 600 degrees centigrade. So what you are getting? Silver chloride and sodium sulfate. That's why it is called as chloridizing roasting. Okay, roasting is of three types: oxidizing roasting, sulfating roasting, and chloridizing roasting. Oxidizing roasting means total sulfide ore is converted into oxide ore. In the sulfating ore or sulfating roasting or partial oxidizing roasting means some of the sulfide ore is converting into oxide ore and some of the sulfide ore is converting into sulfate ore. Whereas in chloridizing roasting, sulfide ore is converted into chloride ore in the presence of some other substance we are heating. Okay, so this is about roasting. Then next, calcination. So second one is calcination. The process of heating of ore below its fusion temperature in absence or limited supply of air in order to remove any volatile matter is called calcination. So what is meant by calcination? Here also we are heating the ore below its fusion temperature, but in absence or in limited supply of air. So why we are doing? In order to remove any volatile matter is called as calcination. So see here, in the presence of air, roasting; in the absence of air, calcination. This method is used to convert an ore into suitable form for the reduction of ore into corresponding metal. So here in this method, we are converting ore into suitable form for the reduction. So at last what we have to do? We have to reduce the ore to get the corresponding metal. So that we are converting the ore. So calcination is generally used for the metallic carbonates, bicarbonates and hydrated metallic oxides. So where we will use calcination generally for metallic carbonates, bicarbonates and hydrated metallic oxides. Calcination does not involve any chemical change and carried out in reverberatory furnace. So whereas roasting involves chemical change, whereas calcination does not involve any chemical change, and this is also carried out in reverberatory furnace. Okay, so you got the difference between roasting and calcination. In roasting, we are heating the ore in the presence of air. In calcination, we are heating the ore in the absence of air or in the limited supply of air. So why we are doing calcination? To remove any volatile impurity present in the ore. Okay, so this method is generally used in carbonates, bicarbonates and hydrated metallic oxides, and this calcination does not involve any chemical change, and this one is also carried out in reverberatory furnace. So we'll see here equations. So carbonates, so calcium carbonate, zinc carbonate, magnesium carbonate, just we are heating. So here heating symbol I didn't write. So in on arrow we can write heating symbol. So when convert, they will convert into oxides. Calcium carbonate is converting into calcium oxide and carbon dioxide is removed off. Similarly, zinc carbonate, zinc oxide plus carbon dioxide. Magnesium carbonate, magnesium oxide plus carbonate. Like this carbonates. If any hydrated ore is there, that hydrated ore is also removed off. Hydrated ore also calcinated. So after roasting and calcination, what we will do? We will do smelting. Next step is smelting. The process of separation of metal or its sulfide mixture from its ore in molten state in presence of flux is called smelting. Okay, see here the process of separation of metal. So smelting means the process of separation of metal or its sulfide mixture from its ore in molten state in presence of flux. Okay, in presence of flux, that means we are separating the metal or we are separating the sulfide mixture from the ore in molten state in the presence of flux is called smelting. So during this process, mixture of sulfide ores called matte is formed. So during this process, what happening? Any mixture of sulfide ores are present. That's called matte is formed. It is one word given, mixture of sulfide ores. In this process, ore is melted with a flux and often with a reducing agent. This process is carried out in blast furnace. So what we will do in this process, we will add some flux. Okay. Then we will heat it and we will add some reducing agent because we have to reduce that one. That oxide ore should be reduced. Okay. So that's why we will use reducing agent. So this process is carried out in which furnace? Blast furnace. Roasting and calcination is carried out in reverberatory furnace. Whereas this one is carried out in blast furnace. Okay. So what is smelting? Simply the process of separation of metal or process of separation of sulfide mixture from its ore in molten state in the presence of flux. That means by adding flux, we are heating that one. So we are extracting, separating the metal. So that is called as smelting. Okay, during this process, what is happening? The mixture of sulfide ores called matte is formed. So here we are adding flux and we are adding a reducing agent and we are separating out the metal. So this one is carried out in blast furnace. So here we will see formation of mixture of copper and iron sulfides from copper pyrites. Okay. So when copper pyrite means here copper, iron, sulfur combination is there. So here what we are doing, we are heating in the presence of oxygen. So what happening? This formation of mixture of iron and copper sulfides are forming. That means from this copper pyrites, we are separating these two, copper sulfide and iron sulfide, and sulfur dioxide is there. Then second step is separation of iron from hematite. So iron, hematite means iron oxide. From this iron oxide, you have to extract this iron. That means you have to reduce this iron oxide. So what we are doing, we are using one reducing agent, that is carbon. So, and we are adding here flux also. So then we are heating. What is happening? Iron is coming separated out and it will be removed off. Carbon will be removed off in the form of carbon monoxide. So like that you can separate the metal from its oxide ore by using reducing agent and by adding flux. So like this we will extract the crude metal. So after removing the impurities, what we will do? We will do extract the metal. So extraction can be done in 3 steps, that is roasting, calcination and smelting. So roasting is again of 3 types. Roasting means heating the ore in the presence of oxygen. During roasting, chemical changes takes place and done in reverberatory furnace. Roasting is first one is oxidizing roasting. In oxidizing roasting, total sulfide ore is converted into oxide ore. Generally, sulfide ores are converted into oxide ores in roasting process. So total sulfide ore is converting into oxide ore in oxidizing roasting. In sulfating roasting, some of the sulfide ore is converting into oxide ore and some of the sulfide is converting into sulfate ore. That's why it is called as partial oxidizing roasting and or sulfating roasting. And last one is chloridizing roasting. So here what is happening? Sulfide ore is converted into chloride ore. That's why it is called as chloridizing roasting. And calcination means process of heating the ore in the absence of oxygen. Okay. So during calcination, no chemical change will take place. This one also done in reverberatory furnace. So in calcination, which ores are converted into oxide ores? Carbonates, bicarbonates and hydrated metallic oxides. Okay. So here examples I have given the carbonate ores. So these carbonates are converted into oxide ores and the impurity will be removed off in the form of carbon dioxide. So after during roasting and calcination, we will convert the ores into whatever may be the sulfide ores, carbonate ores, bicarbonates, carbonate ore, oxide ores. In smelting, what we will do, we will reduce that oxide ore. That means our aim is to extract the metal. So here we have to reduce the metal, reduce the oxide ore by adding flux and by adding some reducing agent. That is called as smelting. So in smelting, you can separate the metal or you can separate the sulfide mixture from its ore in molten state in the presence of flux. So here I have given two equations of, that is, separation of the sulfide ores. So here we are separating the copper pyrites, copper sulfide, iron sulfide, and we are separating the iron from hematite. So this is iron oxide. We are reducing this one. We are removing the oxygen. So iron is separating out. Okay. So like this we will